get started. My name is John Conway. I'm the automation sales manager for Rexel Western New York, which includes the Cheektowaga branch and the Jamestown branch. And this is our monthly modernization series. As the slide here says, we're at part 3 this month, intelligent devices. And we're fortunate to have 3 of our specialists, Steve Fry, who's transitioning into a new role for smart components, and I'll let him explain a little bit about that. But Steve's been with us for over 20 years, and he's seen it and done it, from everything from motion to automation to most recently DCS or Plant PX type systems. And now he's going back to where he kind of started in the industry with industrial components, safety sensors, and IO. So we're excited to have Steve talk. He'll probably have most of the presentation today. And then we have 2 of our specialists from the Power Group, Matt Barton, who's been with us. Is this your 5th year, right, Matt? I think with us going into your 5th year
in December.
Yeah, so congratulations on that milestone. And Matt is kind of our MCC specialist, both low voltage and medium voltage. And he also works very closely with William Walk, who we're fortunate to have is always in high demand, our drive person. William's been with us similar to I think William and I started like a month apart. William's been with us just heading into his 4th year, and we're fortunate. He is a Marine. I know that's something that there's no such thing as an ex-Marine. So William, thank you again for your service, and thanks for being part of the team. So again, this is number 3 in our series. This is the intelligent devices, or how to be smart about your updating your manufacturing modernization. The guys will cover a lot of that. Our next one is visualization, a little promotion for our next one in March 22nd, a month from today. And that'll be led by one of our earlier, Bob Berry and his group, and probably it'll be a team approach. So a few housekeeping here. We are recording this, and we do log it into our Rexel YouTube station. If you haven't gone there, you should. Rexel USA Automation. A lot of good content there, and this will be added to it. And we do ask that you stay on mute, and at the end we'll open it up to questions. But if you had any questions while the presentation's going on, just put it in the chat. I'll be monitoring it, and we'll bring it up to Steve or whoever's speaking, and we'll try to answer it. So again, thank you for all joining us. I'm going to turn it over to Steve to lead us, and the other 2 will jump in as appropriate. Steve Fry, all you.
All righty. Thank you, John. Okay. Before we get started, as the slide indicates, this is intelligent devices. And so what we'll talk about, before we get started, is what is an intelligent device? Most of us obviously are familiar with 2, 3, 4-wire devices, both input and output. And they're primarily just on-off devices. Status information, diagnostics, things of that nature generally aren't included. And if they are, it requires additional wiring. Well, intelligent devices, a little bit different. First and foremost, we convey information over network. They're network enabled. Many times they're self-aware. They have information regarding the status of their health, of the general condition of the sensor. There may be status or not prescriptive, but analytical not analytical. I'm coming up with the wrong words here. But anyway, there's a lot more. There can be a lot more information depending on the nature of the intelligent device than simple 2, 3, and 4-wire devices. So, with the thought of what intelligent sensors are, obviously, they need a connected enterprise to gain maximum advantage. And so when we talk about a connected enterprise, what we're really trying to do is to take a modern control system and take advantage of the value of the connected enterprise what we do with that is we basically take and create analytical information that we use to leverage right information at the right locations, which will generally help lower costs, higher availability, things of that nature when we use connected systems and connected devices. Okay, smart connected systems. In the center, highlighted, is our smart devices, and it's typically surrounded by other parts of the system, integrated control and information, the control system itself, the Logix controller, HMI, things of that nature. There could be additional components like information software that could be both server-based, or it could be edge, like you're seeing so often. We have a supplier that can supply edge-type computing devices. And then what we do with this information is, it's available, as I mentioned earlier, for analytical reasons, and it helps us, perform better, be up, more frequently, less downtime, things of that nature. We can use this information both locally and through mobility, like a cell phone. And finally, security is important. So all those things that surround smart devices are important. If it's executed well, a smart system can be, as the slide says, it can be simple, it can be cost effective, and it can most importantly reduce risk. Okay, it enables greater connectivity. I alluded to this in the opening statement that these sensors not only have the basic information of on off, but status information and health and what's the general state of the sensor. Is it functioning? Has it failed? Things of that nature. They can reduce complexity, certainly, of the troubleshooting, and they can, in some cases, even provide automatic diagnostics. And finally, they enable flexibility and mobility to help drive our productivity. A couple things that you might want to consider as you start to look at the use of connected systems and smart intelligent devices is some of the services that Rexel provides as an authorized service provider. Probably the biggest, most significant one would be the asset management, the installed base evaluation. What we do there is we come in with our engineers and technicians. We basically, on a per panel basis, take a look at each panel and come up with an inventory, if you will, of that panel, both the legacy and how current it is, if you're at risk of anything. And, when you're looking to upgrade, to modernize, it's fairly important that you start with an IBE, an installed base evaluation. Some other things that might be of value, we keep talking about, we do intelligent devices over networks, primarily Ethernet, although we'll talk about some other networks here as the seminar progresses. But you may want to think of maybe some of our services in the area of network assessment, our machine level network design. And of course, as you can see from the list, we have a lot of other services available, but those are the three that I think pertain to today's topic. Intelligent devices. We're going to get started here. Here's an overall architecture with smart sensors. You can see at the very top, you have the things you're typically familiar with: visualization, information software, good old standard controllers, logics and compact logics, a design environment. And then right beneath that is typically, a network, Ethernet. And in this case, the sensors on the left, I mentioned there will be some networks other than Ethernet that we'll talk about today. Well, we're going to mention IO Link. I don't know if any of you are familiar with the IO Link and IO Link devices, but it's generally, I think of it as a sensor network. What you have what we call an IO Link master, and basically it takes both standard and IO Link products, proc switches, photoelectrics, ultrasonics, even instrumentation, process instrumentation, can communicate their status and their overall situation via the IO Link master. And you can see there's round circles on that. That would be your individual channels. In this case, this would be up to 8 channels. And on the other side of that, it connects to the Ethernet network that connects to our network of controllers and visualization. I like to think of the IO Link master as kind of a specialized Ethernet adapter for specialized IO Link sensors and outputs. Outputs could include a bank of solenoid valves, for example, just to give you an example of an output. And then on our right, we have more advanced sensors that require a little more configuration initially when setting them up, and maybe more information on their general information that they're collecting. So these are done via Ethernet IP. So just to give you a little more background about what some of these devices are, these smart devices, and these are a good deal smarter than the proxies and the photoelectrics and the ultrasonics we were talking about just a moment ago. We have what we call this reconfigurable 3D sensor, okay? And what you have is 64 configurable virtual sensors, and it can act like many, many photoelectrics. Just by taking advantage of what it is. So what can I do with this reconfigurable sensor? It can be used for a lot of things. The virtual sensing zones can be created to evaluate height or distance of a missing or misplaced object or product, for example. Could be layering validations on a pallet, for example, bin fullness, validation, rough measurement. These are all the things that this configurable sensor can do, and it's smart. It is configured using Studio 5000 software. We have what we call an add-on profile, and it makes it fairly easy to configure. And then, of course, the additional information as part of its overall operation, that all comes over the network as well. Here we have another example of a smart sensor, much more than some of the IO Link that we were talking about, a code reader. And as you can see here, I think we're all familiar with code readers, maybe not so much in an industrial environment, but certainly in our everyday life. And just like the code readers that we experience in stores and warehouses and all the places that we find ourselves at any given time, this one can be used and ties to our Logix controllers, again, via an add-on profile and Ethernet IP. The status, the diagnostics, all that kind of stuff that you might need for a smart sensor like this is all communicated over an Ethernet cable. Anyway, that kind of concludes that piece of the smart sensors. And now we'll talk a little about smart safety devices. Again, everybody's familiar with 2, 3, and 4 wire safety devices. Well, here we have a network that we call Guard Link, and Guard Link will allow us to, like IO Link did to standard sensors, safety sensors, we have a network that ties us back to our control system. Initially into the adapter, and then finally into the control system and network via the Ethernet network. That's on the left. On the right-hand side, again, we have devices that require a little more than the IO link, or excuse me, the Guard link could provide us. And so we have, we're back to using Ethernet to convey information about the sensor. It, not only its general health and status, but, the production data that it ultimately is going to convey to us. I don't want to say production in this case. I guess maybe I should say the safety information that we want to convey, done over Ethernet cabling. So the first one we have is the 450L light curtain, and unlike other light curtains, this one talks over Ethernet, and even more significantly than that, it's SIP safety, which means I don't need any other safety devices to interface this thing to my controllers. Everything I need to do is over that Ethernet cable. We'll talk a little more about this and some other devices like drives and motion controllers, but this is fairly significant and saves a ton of effort in time and wiring. We have another device a little different than a light curtain. I think most everybody, I didn't talk much about the function of a light curtain, but here we have what we call a scanner, and it basically sets up, I like to kind of think of it as a configurable floor mat, if you will, okay? And again, it's done over Ethernet, it's configured over Ethernet, and it's SIP safety. Really, I just wire the device to the network, and that's about the end of it. I have to power it, of course, but again, really, really simplifying the time it takes to implement because it's SIP safety. And the last thing we're going to talk about in safety devices is an encoder. It's all over an Ethernet cable, and it is SIP safety, meaning I don't need any additional devices to make it safe. I can use it to monitor speed in a safe zone. I could use it to monitor direction. I could use it in a lifting situation. I don't know how many different applications it might have, but these are all devices that are smart, that they wire over an Ethernet network, and because they're SIP safety, they're easy to implement, and they're safe. And that brings me to Matt, who's going to talk a little about power. And excuse me.
Good morning. Can everybody hear me good? Can you hear me, Steve?
Yes, I can.
Good. So let's round up the conversation with some discussion on what Rockwell offers for smart motor control. So whether it be fixed speed across line starters, variable speed, which are VFDs or drives, or motion control. Across all these modes of motor control, we are able to use Ethernet IP and have them networked. Next slide, please. So in these first couple of slides, I'm going to be talking about some of the changes Rockwell has been making towards their fixed speed motor control protection. The E100 overload relay has been discontinued as of last year and replaced by the E100. So some of the changes include improved application coverage with adjustable trip class of 10 and 20 for the basic model. The old basic model with the E3 Plus only had a trip class of 10. And in fact, I'm just kind of backtrack a little bit. There's two different models with the E100. There also were with the E1 Plus. You have a basic model. In this case, has the 10 and 20 trip class, over 110. And then you have the more advanced model where you can get accessories and so forth and go that route. And it is more trip classes. So, for example, your trip classes, instead of just being a 10, 20, be a 10, 15, 20, or 30 in advance, along with a bunch of different accessories. Better current ranges on the basic model, 0.1 all the way to 100 amps, as opposed to zero point 0.1 to 45 in the E1 Plus. And then optional accessory modules, that's a whole animal that's changed the E100 from the E1 Plus. So in the E1 Pluses, they used to have sidecar modules, whether it be the jam protection, the ground fault protection, anything like that. They had sidecar modules. On the E100, that is getting changed to where actually the modules go on the front, and in fact, they're going to be mounted on a little plate that goes on the contactor itself, whether it be the 100C or the 100E contactors. And then kind of a nice thing to know on these guys, the dimensions are very similar. So they'll be more or less plug and play. I think there's one or two models where it's a little bit bigger or smaller. But for the most part, it's a plug and play situation where, if you're taking an old E1 Plus out, you're putting a new E100 into the contact, you've got the stabs, you can go in there. And if you're not using Allen Bradley overloads or Allen Bradley contactors, rather, you can use the pass-through style where you put the wires through and you just put them down in the terminals, you screw down the terminals. So you can also use these on non-Allen Bradley contactors as well. Next slide, please. So our next option is the fully networked overload relay, which is the E300, which replaced the E3 Plus. In fact, replaced the E3 Plus a little while ago. We've been using the E300 for a while now, but that's got quite a few differences as opposed to the E3 Plus. So the biggest difference is modularity. So as opposed to the E3 Plus, which used to be just one solid unit that you got, the E300 is now a modular device. And yes, you do need all three modules to make the E300 work. They consist of the sensing module, and that's connected to the contactor, whether it be step style or pass-through. The control module, which is where your I/O and control voltage are. And the nice thing on the E300 is the I/O, actually it's removable terminals, so it's easier for installation. And then lastly, the comms module, which can either be Ethernet, DeviceNet, or also actually, and they recently did this in the last half a year or so, added a module which is called the E200, which allows you to use the E300 without having it be on the network. You still get all the same safety features and so forth. And you actually program it via CCW, which is Connected Components Workbench, a free software that Rockwell offers. You don't hear free too often, so I like to promote that whenever I can. But that's for programming and setting up the parameters and so forth. And the E200, a lot of your drives have that, our soft starts have that, some of our safety items have that as well. As far as dimensions go, the dimensions on the E300 are it's a little bit deeper, so you got to take that into account as opposed to the E3 Plus. And then as far as the E300 is used with the Series B control module, it supports E3 / E3 Plus overload relay emulation mode, which when attached to a DeviceNet COM module, this allows the user to reuse configuration parameters from the E3 Plus. So if you still want to use that stuff and you want to make it an easier transition when you're going from the E3 Plus to the E300, that's the route you would go. There's also on the E300s, there are also operator stations that can be purchased. These are used for start, stop, reset, and diagnostic purposes of the panel. So you got two different options as far as the diagnostic station. You have a standard little control station that just got the little buttons on it. It's a 20 millimeter. You put a hole in the panel. You plug that right in. There's a spot to plug it in. I think it's a little phone cable along those lines. You plug right into the E300, and you can control it that way. And then also there's a more advanced diagnostic station that actually has a little screen on it to show you some information, whether it be power or amperage or voltage or going over. And the last thing I wanted to mention about the E300, which is also a really nice feature that also I believe a bunch of our drives have, but that's automatic device configuration. So for example, if you have an E300 that takes a dump on you and dies, and you have that parameter set saved back in your controller, you can plug the new one in and a couple easy keystrokes, and then all those parameters from that original that died on you, that will go into the new one, and it's a lot easier as far as install and replacement. That is all I have on my side of things for the smart motor control as far as the cross-line starting goes.
Steve, were you going to present the motion?
Sorry, I was on
Okay.
mute.
That's okay.
Okay, I'm going to talk a little about our scalable motion offering. With the exception of the K5100, the 5300, the 5500, and the 5700 are all what I would like to think of as, again, getting back to these smart devices. Most everything is done over the Ethernet cable. The 5100 is really meant to be a standalone controller. I don't know how many of you guys are familiar with what we call our integrated motion, but it is not part of that integrated motion that we do with the Logix controller. It's meant for simpler applications, maybe that might be used with a Micro 800 or a small Micrologix controller, something of that nature, but it's standalone. And it's configured separately, not in Logix. Starting with the 5300 and the 5500 and 5700, these devices all have the capability to be configured in Studio 5000. They use our integrated motion, meaning we have embedded motion instructions in our Studio 5000 software. Speaking as a former motion guy, they're really quite easy to use. And the beauty of it is, so often we learn things over and over and over again because we have to, because things keep changing. I did motion starting back probably, believe it or not, 16 years ago. And so much of what I learned in motion 16 years ago, yeah, it still applies. Okay. Now, some of the things that we do a little bit differently, back when I was doing motion, safety circuits had to be hardwired. Okay. Well, guess what? With the exception of the 5300, the 5500, and 5700, they're SIP safety. Okay. Again, I'm not hardwiring any safety. So easy to create motion and easy to wire the safety that's so critical in a motion system. And then the diagnostic information, the status of the drives, again, that is all communicated. These are smart devices. And I got a little ahead of myself here, but modernization to what they call K5000 series, as I mentioned, well, let's just start at the left. Okay, the Studio 300 or Studio Kinetics 300. That was a standalone controller, and the Ultra 3000, another standalone controller. They have been replaced by the K5100, or will be replaced. I'm not sure of their status long term. And then finally, when you get into the integrated motion, we use there was the Kinetics 350. And the Ultra 2000. In my day, we used a bunch of those things. But in today's world, they've been superseded. And, the fact that the 5300, the 5500 and 5700 offer SIP safety, do everything they did and make it easier and probably less expensive, it makes it easy to modernize and want to modernize. And here they show a scalable architecture. We're using the 5100 with a little Micro 800. It's standalone controller. I don't know how many of you in the audience may be familiar with the Micro 800. But the standalone nature means it's doing motion independent of the controller. The controller just gives it some general direction when to execute the index, things of that nature. On the right, we have, what I like to think is a more conventional way of doing motion using a compact Logix. It could be a control Logix, but it uses the integrated motion. And on the integrated motion, these motion controllers, like the starting with the 5300, the 5500, and the 5700, they're stackable. They take up a lot less space. And in the case of the 5500 and the 5700, again, they're SIP safety, keeping my wiring to a minimum. And I'm rapidly running out of time here, so I've got to get William up here, okay?
All right. With us? Yep, I'm here. I thought I wouldn't have much time to talk here. Okay, so VFDs. Majority applications are going to be using VFDs, whether you have fans or pumps or anything like that. Maybe you got valves on there and you're using starters. Why not try to choose a VFD for that? Let's go to the next slide. So for our component class drives, just looking at a couple of these here, we have the PowerFlex 523 and 525. They're very similar products, but there's a few key differences. So with the similarities, they both have pretty easy ease of integration when it comes to doing Ethernet. 525 has built-in Ethernet. With the 523, that's optional. Both are programmable through CCW or Connected Components Workbench, as Matt has mentioned, or you can go through the keypad. With the standard USB upload and download configuration, there is a way that, well, actually, let me take a step back. For the USB upload and download configuration, there is a removable faceplate on the VFD, which I'm going to mention in the next section here. You can actually take that to your desk and program the VFD with you at your own workstation instead of having your laptop out there in the panel to do it. This is easy to work with when you're working with Windows 7, but if you're working with Windows 10 and 11, you have to select that as an XP device, and then it will work that way. Now, as I mentioned before, with the control section of this, replacement of that is very easy. You just have a tab up at the top of that. You just pull that out, and you can change out that section. It makes for quick and easy troubleshooting of the VFD. That can tell you whether the power section / inverter section of the drive is out, or if the control section might have an issue with it. If you have automatic device configuration configured in the VFD, then you don't have to worry about any mismatches on firmware or having to reprogram the drive yourself. Key differences between the 523 and the 525. The 525 has safe torque off as standard, is not optional on the 523, and the 525 has built-in Ethernet. Again, these are all very easy to incorporate when you're using Ethernet and utilizing the add-on profiles for those drives. Next one. Similar to the 523 and the 525, we have the PowerFlex 753 and 755. Similar integration with that. If you're using the Ethernet modules, integration into Logix is very easy, especially for the 755. It already has the built-in Ethernet into that. With the 753, you do have the option of adding in a dual port Ethernet card. Both also have options to expand the I/O inside of the VFDs, so you can configure your I/O requirements or communication via that way, or it had any other safety options with there. Now, some of the key difference between those, besides the 755 having the built-in Ethernet, the 755 has integrated safety on that, and that can be controlled by Ethernet. So you have Ethernet safe torque off, or Ethernet safe speed monitor, anything like that. The 755 too, I won't touch too much base on this. You can also use those as motion devices, so they can take motion commands. All right, next slide, please. Now, when we're really talking about intelligent devices, really want to review the PowerFlex 755T. Very similar to the integration in Logix if you're using that via Ethernet IP and the add-on profiles. But we have a couple of pretty cool features when it comes to the 755T. We have adaptive control, we have load observer, and we have some tuning in there. The drive will actually make changes on the fly to compensate for any sort of increased load on the drive, as well as mechanical wear for the best performance Another really awesome thing about that too is the true predictive maintenance. When I think of intelligent devices, this definitely comes up. So imagine you have a gas tank in your car, and that's going to give you real time how much range you have left on your gas tank. So imagine you have fan life or inverter sections of the life in the VFD telling you exactly how much time that piece of the drive might have left. So instead of waiting for a failure or having to do a regular preventative maintenance on that, you can have the predictive maintenance and plan ahead of time instead of waiting for a downtime event for that. As well as having the predictive maintenance for that too, we also have simplified maintenance. So any sort of replacement modules, like anything that's using the rolling carts or fans, they're all replaceable within 5 to 10 minutes once you have it powered off and you're ready to go. And that's all I got for drives.
I have a question for you, Steve, if others want to think about one, but you threw a lot here, right? You covered a lot of products across a lot of different of our segments. And one thing that I always think when modernization, a lot of people just see a lot of this as new product I got to rip out and replace. Is what do we do? I know you talked about a little bit about the assessments that we could go in and see what they have, but is there a way to use some of their existing legacy equipment, not have to rip it all out at once?
Well, sure. There, in the case of hardware, for example, we have RTB terminal block assemblies that make converting an older legacy PLC5 or a more current SLIC fairly easy to convert, because you don't have to reland a lot of wiring. Maybe you don't have to reland any using the conversion RTB modules. So that comes to mind.
Some of the things I was thinking, and maybe Matt or William, if you wanted to add anything on your products, but I think for customers to know that there are ways to use some of the older analog equipment and specific to maybe even drives, or use some of the ProSoft, not always Rockwell product, but use some of the connectivity and communication bridges, if you will, out there to take advantage and not have to, you want to have a plan, really, is what I'm getting at. And everybody has a budget. Nobody has an unlimited budget. So it could be, no one's disagreeing that it's going to be expensive to modernize. But I think if you start out with an assessment of what you have currently, it's well documented, all the equipment, all your panels, your network, and from there have a plan over the next period of time. If you're in a 5-year type plan and you want to do one section or one area, we find that to be the most successful plans. And again, we would love to come out and talk to folks about that and work with them on that type of thing. So I'm going to cut it off here, Steve, only because we're a little bit over, and it doesn't seem like we have any questions other than what I asked. So thank you for your time. Both you and Matt did a great job, and obviously William, thanks for taking the time to do this, and appreciate it. The next one is up a month from today in March on visualization, or really automated diagnostics, as you can see on the screen. So thanks again. Everyone have a good day.